So we put all of what we did together in one big lovely equation, and each of these capital letters represents what they call a parameter, something that's going to be changing how the equation looks and behaves. Your textbook suggests, and I agree with them, that when we actually start doing the graphs on our own, that we use the edges, the outside edges first. So this first A here, that starts with an A. This represents the amplitude. The vertical stretch factor, and actually the absolute value of A equals the amplitude. We don't have a -3 amplitude. The negative out front just tells you there was a vertical flip. So if this multiplier out front is negative, we know we have a flip across the x-axis. And it's going to tell us how high and how low above center. So if we had a 3 here, it would tell us wherever the center of the wave is, that the graph is going to go 3 spaces above that center and 3 spaces below that center. The B we talked about just a few minutes ago, that can be thought of as the frequency. The cycles, the number of cycles in the original period. Which could be 2 pi, could be 360. If we were dealing with a tangent graph, it would be just 1 pi or 180. And that also tells us what the period of one cycle is. We take the old period, divide it by b, and we get the new period. The plus c here, that moves it left or right but in the opposite direction. A plus c moves it left, and a negative value c moves it right. And this is called, in wave function terms, this is called the phase shift. Now I have to be honest, your textbook puts a minus sign in here to remind you to take the opposite. But they didn't do that earlier with some of the other functions. And when I look them up on the internet, half the equations have the plus sign here, where you're just supposed to remember that it's in the opposite direction. I mean, they don't make this 1 over b. We're actually dividing by b here. But in your textbook, they're like the other half of the world who puts a minus sign there. We can adapt either way. And the D on the end, that is the vertical translation. The vertical shift, I'm going to call it, because that's easier to spell, and that's going to move up or down. And this is an interpretation of this major equation that we can use to put all these transformations together. So if we have an equation that sort of puts some of these things together for us here. I borrowed this from another textbook. And they put the 3 first. A lot of the world, like y equals mx plus b, b is the y-intercept, a lot of the world puts the y-intercept first because that's where you begin on the graph. And that is actually where we're going to begin. We're going to begin with this d here, which besides being the vertical shift, in wave notation, this is also the axis of the wave. It is sometimes called the center of the wave. So instead of oscillating back and forth across the x-axis, it's going to be oscillating back and forth across whatever that number is. And that is actually what we should be graphing first, because it's the center of the action, literally. Everything else is going to be moving around that new axis. Sometimes it's called the axis of translation, but that's way too much to spell. So if that will look more like this formula up here, we can change this to y equals 5 times the sine of 2x plus 3. And the plus 3 on the end tells us that the whole graph, the whole sine function is going to be moved up 3 spaces. So I'm just going to draw a line here. I hope it'll be straight. I don't know. That is our new center of the wave. It's not going to be going up, flopping up and down across the x-axis. It's going to be flopping up and down across this new center. At the other end of this big equation, the amplitude tells us it's going to go 5 times higher than its center. It's going to go 5 times lower. 5 units higher than its center, 5 units lower than its center. Instead of going up 1 space like the normal sine function does, it's going to go up 5 spaces. So if it's right at 3 now, it's going to go up to 8. And down 5 spaces from here, it's going to go down to -2. And I didn't space them evenly, I can tell already. I'm going to put a dotted line here. Dotted line here at 8, and a dotted line down here, wiping out all the numbers at -2. Now if I'd drawn this correctly, this space would be the same as that space. And this is where our function is going to be moving. This is kind of like its highway. Here's the median, here are the edges of the road, and it's going to be traveling up and down on that roadway. The amplitude helps us define its boundaries. Okay, so we've got some other things going on. There is nothing being added or subtracted from the x. So this particular equation has no phase shift. Which makes it easier. Sorry about that. It does, however, have this multiplier on it, which is the frequency. It tells us that we're going to have 2 cycles in what used to be the original period. So it's going to have 2 cycles in 360 degrees. It also tells us that the new period is going to equal the original 360 divided by 2. So it's going to have 1 full cycle every 180 degrees. Now I went with the degrees because that's how the original graph was labeled. I have to be honest, most of the functions in real life don't use degrees. They use radians and pi. So the sine function, I'm hoping you know the cosine starts at the top, the sine starts at the bottom, at the middle, and negative cosine would be down here at the bottom. So the cosine normally starts here, goes up, goes down, goes up, goes down. Well, it's still going to start here, right in the middle, right on the axis of the wave. And it's going to do one whole trip by the time it hits 180 degrees. And it's going to do another whole trip by the time it hits 360. And then every 180 degrees after that, we're going to have another complete cycle. We're going to have a complete cycle here by the time we hit negative 180. And this is going to be its middle. And it's going to go up this high, come back down again, go down to here, come back up here. Good night. Good night. Sorry, teacher just walked out. And now I totally forgot what I was doing. It's going to have another cycle by the time it hits here. So it's going to go up, down, all the way down to here, back up again, another cycle by here. And I think you get the idea. This thing's just going to keep oscillating back and forth and back and forth. It wasn't supposed to go through that number. It was supposed to come over this way. And we can have that happening again here. And it's a little wobbly, but that's the graph of our 5 times the sine of 2x plus 3. So let's try another one. And some folks like to write down all the information first. I'm still going to write it in the order that we'll graph it. So the number on the end tells us the new axis. It says vertical translation. The new axis is going to be y equals 3. Everything's going to be centered around that horizontal line. And at the other end, the 2 tells us the amplitude. It's a positive 2, so we're not going to do a vertical reflection. The amplitude is 2, which means that our wave is going to be going 2 spaces above 3 and 2 spaces below 3, which we're going to sketch in a minute. We have, this affects the period, this is the phase shift. Doesn't matter which one we do first, I'm going to go with phase shift. And because there's a subtracting one, the phase shift is going to move to the right 1 space. So this isn't degrees, and I hope it's not going to stay radians, because 1 radian is kind of messy to work with. Okay, so this tells us the frequency. We're going to get pi over 2 parts of a cycle done. Sorry, we're going to get pi over 2 waves done in the time we normally get 1 cycle. So this is about 1.57 waves. In the normal 2 pi. I totally messed up. Oh well. And we're going to have to find the period, and the new period equals the original 2 pi divided by this thing, this b thing. But that's just multiplied by the reciprocal, so we have 2 pi multiplied by 2 over pi. And the pi's cancel out, and the period is just 4 units. And this is one reason why they use radians in practical applications, because the degrees carry their own unit on them, the radians don't. So if we wanted this to be 4 minutes, we would use radians. So we're okay here to go ahead and start the process. Graph at y equals 3. That is the new axis of the wave, which I sort of missed there. And it's going to be going amplitude of 2, so it's going to be going 2 spaces higher than that, up to 5, and 2 spaces lower than that, down to 1. And the entire wave is going to have to keep waving back and forth between those. It's time now to try to draw the graph. We do know that it's cosine, so that usually starts at the top, goes down, comes back up to the top again. We know that it's not going to start at the top on the y-axis. It's going to start at the top at 1 because it has a phase shift 1 to the right. And then it will do 1 complete cycle and be back up to the top again when x is 4. I'm sorry, when x is 5, my fault. When x is 5. Because this period across here is supposed to be 4 units. It's got a period of 4. So from 1 to 5 should be the space of 1 complete cycle. So if this is 4 spaces in here, it should be bottoming out right here at x equals 3. Coming down something like this. Bouncing back up again here. And that will repeat again in another 4 spaces. So that would take us from 5 to 9. In the middle, it'll bottom out at 7. And we could do the same thing going 4 spaces this way. It should top out at when x equals -3. It should hit the bottom when x equals -1, because that would be 4 spaces from -1 down to -3. And we have our graph. We could continue another part of the wave over here if we wanted to. Now they said that it takes about 1.5 radians for 1 complete cycle. That's looking a little strange there. So 1 cycle. Oh, we got 1.57 waves in 2 pi. My fault. So we get about 2 pi would be right here, about 6. We do not get a whole 2 waves. We get like 1.5 and a little bit more waves by the time we hit 6.28 here. So they are tricky. They take patience and they take time, and I'm sorry that I am so bad at drawing. But we do have to learn how to go the other way. This is actually from your textbook. I just tried to make it easier. So they want us to do it in reverse here. they want us to write an equation for the graph that we're given. And we can put it all together. You know, accumulating the period and the axis and the amplitude, all that good stuff. And we have a choice. Actually, there are an infinite number of equations we can write for this particular graph. I'm going to try to pick the easiest one. Now we could go with sine, but it doesn't start where the sine graph starts. The sine graph would start here. So if you're going to pick sine, unless we chose negative sine, then we could be here. But if you're going to go with plain old sine, we would have to start right here. We would have to use a phase shift of 3 pi over 4. Right along the y-axis when x equals 0, this graph is at the top of its curve. So I would pick cosine. The sine graph will work. I would pick cosine because we won't need a phase shift then. That's one less step to worry about. So I'm going to go with y equals something happening to cosine of something plus something plus something. The axis of the wave, well, one way we can find the axis of the wave, or the center of the wave, is to take the maximum y plus the minimum y. Now we did the maximum y minus the minimum y divided by 2. They gave us the amplitude. So this time we're going to take the highest y value plus the lowest y value and divide by 2. So we go as high as 5, it looks like, and as low as -1. Divided by 2 is 2. So that's telling us at y equals 2, that's the center of the wave. And it does look like that. It does appear to be correct. So that's going to tell us the part on the end. Whole bunch of stuff here, plus 2 on the end. We know who D is. We can find the amplitude. We could, because we know the center of the wave, just count the squares above, count the squares below. We could do the amplitude by doing what we did earlier in the year, by taking the maximum y value minus the minimum y value and divide by 2, which would be 5 minus -1 divided by 2. And that's going to give us an amplitude of 3. And the graph is going 3 spaces above its center, 3 spaces below its center. So we have that end done. We just have to fill in the middle. Is there a phase shift? Is the cosine graph getting moved left or right from center? And thankfully it isn't. So we won't have to put in that we've got some kind of phase shift going on. So that's nice. Is the period 2 pi? Does it take from 0 to 2 pi to get one complete cycle? Now we're working from the graph, so I have to look at the graph. And one complete cycle takes 1 pi. Now the 1 pi isn't what's going to go in here. We're going to have to figure out who the b is. Because the equation is y equals amplitude times the cosine times the b that affects the frequency and the period, times, in this case, it's not x minus anybody, and we have a plus 2 on the end. Now you might be able to tell just by looking at the graph 0 to 2 pi is the normal period, and we got 2 full cycles in it. So that's looking like B is going to equal 2. We'll have to check. And my plus 2 here is a little remote. The new period should equal the old cosine period divided by B. Well, the old period is 2 pi. The new period is just 1 pi. And we've got to solve for B. So we can multiply both sides by B. We got B times pi equals 2 pi. And guess what? B equals 2. And that, the plus 2 should be a little bit closer in here. I thought there was going to be more stuff. That would be the equation of this graph. One more of these. Once again, we have our choice. We can choose a sine graph or a cosine graph. For all of these, you can pick either a sine graph or a cosine graph. Whichever one looks like it's going to be easier. Well, the graph is crossing the y-axis right here. This is x equals 0. It's nice if we have a normal function being right there, like the cosine being right on the x-axis where it has its maximum. Well, that doesn't look like that's happening here. If we want cosine, we're going to have to do a phase shift thing. We will have to move it over by 1.5 spaces. Oh, let's see if we can do sine. So the axis of the wave is going to equal the maximum y plus the minimum y. It's the average of the two extreme y values divided by 2. Well, the maximum y is 4 plus the minimum y is negative 2. So that's 2 divided by 2 is 1. That's telling us y equals 1 is the axis of the wave. And it does look like it. It does look like we've got half the graph above, half the graph below. And that sets it up perfectly for a sine wave. We're going to have y equals some kind of sine of something times maybe a phase shift plus d. Well, we already know that it's going to be sine. We already know that it's being raised up 1, the center. So the new axis is at positive 1, y equals 1. Amplitude. We could just count how high above and how low below. It's got to be the same. We could just count that it's going to be 3. Or we could do the maximum y minus the minimum y, divide by 2, and we still get 3. So we know that part. Phase shift. Did the original sine graph get moved to the left or to the right? Nope. It got moved up, but it didn't get moved left or right, so there's no phase shift. We're not going to have a plus c in this one. We're just going to have b times x. And we have to figure out who b is. Well, the new period equals the old 2 pi for sine divided by b. So b is going to equal 2 pi divided by the new period. We're going to have to look at the graph to figure out what the period is. Sine graph starting here, it's gone up, it's gone down, coming back, and coming right to here. Now that's not 6. 6 is here. It's a little bit more than 6. Maybe like, it's not 6.5, maybe 6 1/3, 6 1/4. B is approximately equal to, you know what? I think that's 2 pi. A little bit more, 6.28 radians is 2 pi. And we've got 6.25, 6.33. So I'm just going to go with B is 2 pi. That would be our multiplier here. Because we are getting that, if this is in radians, right about here would be 1 radian. And we're getting 6.28 of them in the time that we used to get just 1. So it's not easy. It takes a lot of patience, and I appreciate your patience here.